Hi everyone, this lesson starts our new chapter 11, sequences and series. So this is day one of sequences. So let's get started. First thing though, let's do a little warm up and write the next couple of terms for each sequence. So before, I would pause the video occasionally throughout the lesson so that you can have a chance to work some of the problems out on your own. So pause the video, this is a good time to do that. Work these problems out and then restart it. So welcome back. For this first one, I would say you're trying to find any kind of pattern that you can so that you can write the next couple of terms for the sequence. For this problem here, it does look like I'm subtracting 7 each time. And so when I'm subtracting 7 each time, my next values are going to be negative 26, negative 33, and then negative 40. And so writing these problems in, when I get those in there, I want to remind you or just inform you that if I'm subtracting the same value every single time, if you are adding or subtracting the same value, okay, and you're adding, of course, the same value, we call that a common difference. So a common difference. And we're going to come back to that later on. But that's what we call that, a common difference. So it's a difference that's common all the way through the sequence. For this second problem here, before I move on, another way of figuring out, like, how did you figure out how to subtract that you were subtracting 7? You're taking the second term, right, for this problem, and you're subtracting the first term. Or you're taking the second term here, and you're subtracting that term. So you're going to get negative 7 every time. And by getting negative 7 every time, because we're subtracting that next value, I'm getting a common difference. And if it's a common difference later on, today we're going to realize that that's what we call arithmetic, an arithmetic sequence. So for this problem, the second problem, it does look like I'm going to take the second term. It's not subtracting the same term every time, but it does look like I am dividing by something. So I'm going to take the second term and divide by the first term. And it looks like I am either dividing by negative 2 or multiplying by negative 1/2. And so for this problem here, if I multiply by negative 1/2, I'm going to get positive 3/4. And then I'm going to get negative 3/8. And then I'm going to get positive 3/16. And again, because I'm multiplying by this same value, which is negative 1/2 each time, again, that's a common value, but it's not a common difference because we're not finding the difference. We're not adding or subtracting. We call that a common ratio. So if you are, same thing, if we were taking the same value, and instead of adding, or this one is adding or subtracting, we are multiplying or dividing, but multiplying by the reciprocal. We call that a common ratio. And then we're going to talk about that later on today. So for the next pattern, it does look like it's not a common ratio or a common difference because I'm not adding the same value every time, right? And so it does look low, like I'm adding odd numbers. And so I would add 9, and then I would add 11, etc. So I would get 35, and then 48, and then 63, okay? This one is really tricky and just really one of my favorite patterns here because it's the Fibonacci code, and it was used in the Da Vinci, like the movie Da Vinci Code. But anyway, this one is really interesting because the next patterns are 13, 21, and then 34. And the way you get these is by adding the previous two values, right? So 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 2 is 5, etc. So that's kind of cool, I thought. Anyway, our learning targets, find a pattern. You're going to be writing a few more terms of the sequence. In some of these problems, you're going to try to find a formula. Use the formula to calculate other terms. You could draw a graph. A lot of questions are going to be asking, is it arithmetic, geometric, or neither? neither. And given a value of n, find t of n. And so that's a big deal too. Okay, so we're going to be doing all of that today. We're going to start off with what a sequence is. And a sequence is a function where the domain is a set of consecutive positive integers that begin with 1. So what you need to kind of get in the habit of doing is saying, okay, this value, like even this thing right here, this is the first term. So I'm going to call that t of 1. This is the second term, so I'm going to call it t of 2. This is the third term, so that's t of 3. And this is my fourth term, so I'm going to call that t of 4. So these are my term values, okay? So this right here would be my value, my term number, right? That would be which term number I'm using. And for this problem, I have, for t of 1, the first term has 1 value. The second term has 3. The third term has, let's see, 1, 2, 3, 4, 5, 6, etc. And it looks like that we're adding 2, we're adding 3. This is not arithmetic. Let's see if I can be multiplying. 1 times 3 is 3. 3 times 3 is 9. Well, that's not geometric. So occasionally a sequence is neither going to be arithmetic nor is it going to be geometric. So we just would say this is neither or neither, however you say that. But a sequence in which each term after the first value is found by adding the same number to the preceding term. You're adding the same number, common number. We call that an arithmetic sequence, okay? We call that an arithmetic sequence. And our arithmetic sequence, we actually have a formula for that, which is down here. If I give you this sequence, 2, 5, 8, 11, 14, 17, how do I know it's arithmetic? Well, I know it's arithmetic because 5 minus 2 is 3, 8 minus 5 is 3, 11 minus 8 is 3. See how I'm adding the same value each time? Again, we call that a common difference. And our common difference, or D, for this problem is 3, or for this sequence is 3. So if I just said, find the 11th term, don't be naive and not think that I would expect you to say, well, how hard is it to add 3 11 times on my calculator, or just in my head, right? Add 3, add 3, add 3. I get that you can use that to check your work, no problem. But I actually want you to use this formula, because obviously I'm not going to ask you for something that's going to take, maybe 30 seconds, as opposed to I might ask you for the 50th term, or might ask you for the 100th term. So what if I did ask you for the 11th term, right? This is how you would write it. You would go t of 11, because that's my 11th term. See, that's the term, is equal to t of 1, which is my first term. In this sequence, it's 2, plus n. This is the term I'm trying to find. Okay, that's the term I'm trying to find. D, common difference. Okay, that's the number that you're adding each time. Okay, so this would be times the quantity, n, which in this case I'm said it was 11 minus 1, and then times d. And then for this problem, right, for this problem, d is 3. So we would plug in 3 here. So let me erase this d and put a 3 there. All right, so we would get 11 minus 1, which is 10. 10 times 3, which is 30. 30 plus 2 is 32. So my 11th term is 32. Now, yes, of course, and you would box that up. That's your answer. But of course, I'm going to ask you something, more along the lines of what's the 50th term, or what's the 100th term. So definitely keep this formula handy by you. Okay, write out the first 6 terms. So numerically, my first term, this is just 1 dot. And then the second term has 1, 2, 3, 4 dots. The third term, 1, 2, 3, 4, 5, 6, 7 dots. And then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 dots. Now, and of course, this would go on. So first term, t of 1 is 1. Okay, now we want to write out the first 6 terms, but I only have 4 values here. So I need to be able to come up with a common difference or a common ratio, some number that I'm adding or multiplying the same to all of these. So it looks like if I go 4 minus 1, I'm going to get 3. And if I do 7 minus 4, I get 3. And if I do 10 minus 7, I get 3. So it looks like my common difference is 3. So that means that 10 plus 3 would be 13. 13 plus 3 would be 16, etc. So I can just keep going on this. But I want to find the 100th term. So I recognize that this is an arithmetic sequence. And if this is an arithmetic sequence, I'm going to use this formula to solve. And so if I want the 100th term, I'm going to say T of 100 is equal to the first term, which is 1, plus n being the 100th term. That's this value should be the same, minus 1 times my common difference. And so for this problem here, let's see, 100 minus 1, that's what, 98? And, excuse me, 99. 99 times 3, and then add 1. I know we did this in class, so we are going to use 298. And that's it. Now, if I want to find the nth term, meaning give me a formula for this sequence, and I want it to work anytime I want to use it. So you would say T of n is equal to the first term. So you're just using this right here, but you're plugging in the values. So T of n is the first term, 1, plus n is still n, minus 1 times my common difference. And so this would be a formula to find the nth term. All right. So here we go. I'm asking you to find the nth term of the arithmetic sequence, and we don't know what term number it is, but we do know that the nth term is 301. So we know that the nth term is 301. We also actually know the first term is 4. And so what we would be doing here for this sequence is I'm going to say, well, T of n, my nth term is 301, equals my first term 4, plus we don't know what the value is. We don't know what n is. That's what we're actually trying to find. Minus 1 times my common difference. And again, 7 minus 4 is 3. 10 minus 7 is 3. My common difference is 3. So the first thing I'm going to do is I'm going to, let's see here. The first thing I'm going to do is I'm going to say that I'm going to subtract 4. So I'm going to go 301. Let's see my calculator. I know I can do this, but getting that out. And so we're going to have 301 subtract 4, and I get 297. And that is equal to n, which we're trying to find, n minus 1 times 3. So I'm going to go 3n minus 3. I'm going to add 3. I get 300 is equal to 3n. So n is equal to 300 divided by 3, which is 100. So what this means is that n is 100. So that means T of 100 is equal to 301. So my 100th term, so my 100th term is 301, or 301 is my 100th term. Find the common difference, and actually I think I changed this to the 50th term, okay? But find the common difference and the 15th term for this problem. So for this problem here, it looks like we're adding 5 to each value here. So that's going to be, so D, my common difference is 5. So we're going to say, well, I want to find the 15th term. So I'm going to go T of 15 is equal to my first term plus n, which is my 15th term, minus 1 times my common difference. So my 15th term is going to be 14 times 5 and add 3. So hold on, 15 times 1. So I think what I end up getting is 14 times 5 is what? 70. 70 plus 3, so that's going to be 73. Okay? So that means my 15th term has a value of 73. Keep in mind, I am well aware that it's very easy just to add 5 on your calculator each time to verify to verify that you get 73. That is fine. You're welcome to check, but this right here is work, and I want to see that, okay? What is the 50th term and the common difference? So the 50th term. So the common difference, 5 minus 9, well, that's negative 4. 1 minus 5, well, that's negative 4. So it looks like my common difference is negative 4. Okay, so now I'm going to use my formula because I want to find the 50th term. So T of 50 is equal to my first term, which happens to be 9. So 9 plus the 50th term minus 1 times my common difference. So for this problem, it looks like I have 49 times negative 4, which is negative 196. Add 9, and I get negative 187. So T of 50 is equal to negative 187. All right, and for this problem here, they're telling me it's also an arithmetic sequence, which means I'm going to go 0.12 subtract 0.07. And so to find my common difference, right, I'm going to say, well, that's 5, borrow 0, so 0.05 is my common difference. So using that in my formula, they want to find the 11th term. So I get that. Again, once again, I know that you can keep adding 0.05 and keep going, okay? But let's use the formula. So we're going to find the 11th term. So the 11th term, 11 here, is equal to my first term, which is 0.07, plus I'm looking for the 11th term. That goes right here, the term I'm looking for, minus 1, times my common difference, which is 0.05. And so in this problem here, I end up getting, and you work this out, please, T of 11 is equal to, always make sure that you do this multiplication first before you add that value there. And so I end up getting 1.2, which is my 11th term. Hey, Dad. For this problem here, this is definitely a little bit more challenging, okay? And there's different ways that you can solve this. And so I'm going to write this out. It says that the third term, 1, 2, 3, is 8. And then it says the 16th term is 47. So I'm going to write this out. 1, 2, 3, third term, 4th, 5th, 6th, 7th, 8th, 9th, 10th, 11th, 12th, 13th, 14th, 15th, 16th. So my 16th term is 47. And so this right here is my 16th term, okay? So you would say that that's T of 16. And normally you would say that this is T of 3. But you don't, your job is to find T of 1, which is way over here. However, this is what you need to remember. If this is T of 1 and that's T of 3, great, but we don't have a common difference. So we can't actually figure out that unless we use the information that we have. And the information we have is that if we're just looking at this information, 8 is actually my first term that I have, okay? And that being the case, if T is the first term I have, 2nd, 3rd, 4th, 5th, 6th, 7th, 8th, 9th, 10th, 11th, 12th, 13th, 14th, that would make T of 14 equal to 47, okay? So now based on this information that the first term is 8 and the 14th term is 47, we need to try to figure out how to actually find the first term, but also the common difference. So we're going to use this formula because we know that the nth term is 47, that the 14th term is actually 47. So I'm going to go 47 is equal to my first term as we know it right now, which is 8, plus n, which we know n, because if 47 is our term, this would be then the 14th term, minus 1 times d. So first I'm going to take 47 and I'm going to subtract 8, and I'm going to get 39. 14 minus 1 is 13, d. I'm going to divide by 13, and I'm going to get my common difference to be 3. And that being said, if I know my common difference is 3, then what I can do then is move this back to where it's supposed to be and say, well, if I'm adding 3 each time, right, adding 3 each time, this would be what, 11, and then 14, and then 17, and then you guys can keep adding 3 each time here, but then going backwards, this would be 5, and then this would be 2. So my first 5 terms are 2, 5, 8, 11, and 14. T of 1 is equal to 2, and my common difference is 3. So that's how you set that up. You use the information that you are given, even if you have to move your first term forward, because that's the first term as you know it. That's the first term as you know it. All right, so moving to geometric sequences. Now, geometric sequences are similar to arithmetic sequences in that in an arithmetic sequence, you're adding the same term each time. But with the geometric sequence, you are multiplying the same term each time, okay? And so we call that term that you're multiplying each time in the sequence a common ratio, okay? Because it's like a multiply by the product, right? So you could be multiplying by the inverse, etc. And we use the letter R to represent the common ratio, okay? So what you have here is just saying a geometric sequence is a sequence in which each term equals a constant multiplied by the preceding term. So for this problem, you could take the second term and divide by the first term. So you can go 6 divided by 2, that's going to be 3. And you can go 18 divided by 6, that's going to be 3, which means that I'm multiplying by 3 each time. So that would mean my common ratio is 3, okay? So for this problem, let's say I want to find the 12th term. Now again, 1, 2, 3, 4, 5. This is my 5th term. 6, 7, 8, 9, 10, 11, 12. How easy is it on my calculator just to keep going times 3, times 3? I get that. You are welcome to check your answers on this, on the calculator. However, I do want you to use this formula. And so let's do that. Oh, by the way, yeah, these formulas are on your calculators if you can find them. Okay, so we are going to start with T of n. So if I ask you, hypothetically, I want you to find the 12th term, then what you would do is you would say, well, T of 12 is equal to, because that's their T of n, the first term, which is 2. So 2 times my common ratio, which is 3, to the nth power, this is my n, 12, and then minus 1. And so what I would do for this problem, oh, by the way, you always do or simplify exponents first before multiplication. So you would, of course, do 3 to the 11th power and get that value first, and then multiply that by 2. So the 12th term ends up to be, I think we got, let's see, 354,294 if you just keep multiplying your answer by 3 with your common ratio. All right, that's cool. All right, so find each of the following geometric sequences. Identify the common ratio. The common ratio being R. So for these right here, my common ratio would be 6 divided by 3, which is 2, 12 divided by 6. So my common ratio for this problem is 2. The common ratio for this problem, again, of course, you could go the second term divided by the first term, which is my common ratio is negative 1/2. It's always nice when it starts with 1. But if you want something a little more challenging, of course, you could go, well, what's 1/4 divided by negative 1/2? Well, that's 1/4 times the reciprocal, which is negative 2 over 1. And again, I get negative 1/2. So my R is still, my common ratio is still negative 1/2. For this problem, I would go 1060 divided by 1,000. And in this problem here, what did I get? I got 1.06. I think I got R is equal to 1.06. So my common ratio would be 1.06, which means they're multiplying 1.06 each time here. So then every time I'm multiplying by 1.06. So that's my common ratio. So here we go. We are given the sequence, which looks like my common ratio right off the bat is 2. So R is equal to 2 based on that. I want to find T of 6 first. So I'm going to find my sixth term. So T of 6 is equal to my first term times my common ratio, which we already know is 2, and then to the n minus 1 power. Now remember, that value right there is n. So I want to the n minus 1 power. So that's going to be 6 minus 1. And so, and remember, the nth power, these are the same, right? These values here, those are n. Okay, so T of 6 is equal to 3 times 2 to the 5th power, because of course, you need to do that first. And again, exponents come before multiplication. So 2 to the 5th power is 32, and then 32 times 3 is equal to our T to the 6th power. So T to the 6th power is 96. So that means T to the 6th, not power, but the 6th. So this is what you would say. The 6th term in this sequence is 96. So again, I mean 6, 3, 4, 5, 6. I would just be multiplying by 2, 6, 3 more times. I mean, yes, I get that. You can do it. Find the 7th term of this geometric sequence. So again, I want to find the common ratio. I'm going to go 20. It's telling me it's geometric. So that means I need to divide the second term by the first term. So 20 divided by 4 is equal to 5. And so that's my common ratio. And to check it, I would go 100 divided by 20 and get also 5. All right, so we want the 7th term. It's geometric. So I'm going to use this formula. The first term, which is 4, times my common ratio, which is 5, to the n minus 1 power, 7 minus 1. So the 7th term is equal to 4 times 5 to the 6th power. Again, do this first. Exponents come first. And I get, I'm not sure, 62,500. I believe that's what I get. So the 7th term is total 62,000. That might be an 800. I don't know. Let's see. 5 to the 6th power. It's about 15,625 times 4. 625. And then we go. Here we go. All right. So for this problem, find the 10th term. And again, they're telling me, hey, it's geometric. Take the second term divided by the first. So the ratio is going to be negative 32 divided by 64, and that's going to give me negative 1/2. So my common ratio is negative 1/2. So I want to find the 10th term. So I'm going to go T of 10 is equal to my first term times my common ratio, which is negative 1/2 to the n minus 1 power, or 10 minus 1 power. So the 10th term is equal to, and again, really, really watch yourself on this, exponents first. So you could write it like this, right? Because that's to the 9th power. Negative 1 to the 9th power over 2 to the 9th power is negative 1 over, I don't know, 512 maybe? No, I don't remember what that is. 2 to the 9th power. I can figure that out. 512. It is 512. Okay, so that's what this value right here is. So you're going to go 64 times negative 1 over 512. So that means my 10th term is equal to like negative 0.125. And just a note, when you're doing that, if you want your answer, if you're using, I think it's a TI, it's a TI 84. Of course, the TI Inspire will just give you the answer in fractional form. But if you want the answer, so like, what do? We multiplied 64 times whatever, negative 1 over 512, and we got negative 0.125. So if I go, I'm going to show you my calculator here real quick. If I go, let me quit, second quit, and clear. So if I go, let's see, negative 0.125, right? And you know what that is, a fraction, but let's say you forgot. And you're like, oh man, I really wanted a fraction. I don't want to use I want a fraction, I don't want a decimal. So you go over to here where it says math, and it'll say, here, first value says, hey, I want a fraction, enter. So change this to a fraction, negative 1/8. So that's something that, know your calculator, it's your friend. So that I could, instead, if you're, only supposed to be writing fractions, you can write, that value as a fraction. For this problem here, I want you to calculate the 100th term, so t of 100, for the geometric sequence with the first term being 35 and the common ratio. So this is just making sure that you know how to do this. The first term is 35 times r, which they gave me, which is 1.05, awesome of them, to the 100 minus 1 power. So we're going to go, for this problem, we're going to say 1.05 to the 99th power, and that's going to give me 125 point something. Taking that number, and I'm going to multiply that by 35, and I get 4,383.38, and that equals t of 100. So that means that the 100th term is equal to 4383.38. That's what that means. So for this problem, remember Deadpool? Okay, so for this problem, we know that the first term is 17 and our common ratio is 2. But they didn't give us, they said find n. N is like the term. So we're trying to find out, they gave us this term, right? And they said, well, what number is it? What term number is it? So let's write the formula. So t of n is equal to the first term times the common ratio to the n minus 1 power. So let's plug in the information that we actually know. We know that t of n is this. So we can say 34,816 is equal to my first term, which they did give me, which is 17, times my common ratio. They also, generous of them, gave me that. But they didn't give me n, because that's actually, I'm trying to solve for what term is it, right? And so first we're going to do is we're going to divide 34,816 by 17. We're going to lose the 17. We're going to try to divide both sides by 17. And in doing that, let's see, 34,816 divided by 17 is 2048. So we have 2048 is equal to this value here, which is 2 to the n minus 1. Now, I know you're thinking, what do these things have in common? Deadpool, exponents in the power, and you're thinking, oh, logs. Right. Okay, you guys like my humor, I know. Okay, so here we go, 2048. All right, so I'm going to move that to the other side because I like my logs on the left. Okay. So we're going to take this value up here to pull this out of the exponent's power. It's going to become n minus 1, and I'm going to get log 2 is equal to log 2048. And then our objective is to solve for n. So we're going to divide both sides by log of 2. So I'm going to get n minus 1 equals log of 2048 divided by, and that's base 10, divided by log of 2. Now, for those of you using calculators, you would then take this value, change in base form. This would be log base 2 of 2048. So if you have the TI Inspire, you would do this. You would use this value right here. And just type it in, it does it for you. If you have the TI-84 plus, etc., you just do this and plug it in. It solves it for you. And so you get n equals, now this actually turns out to be 11. So this becomes 11, and then moving this negative 1 over to the other side becomes plus 1. So this means that my value is 12. So that means in conclusion that 3,000 or 34,816 is my 12th term. That's what it means. So you could write it like this: T of 12 is equal to 34,816, like that. Cool. This right here is just like something kind of fun. It's like it's actually famous. It's called the triangle numbers. How many dots will be in the nth triangle? So that's like a little fun challenge for you to try to figure out, and you can definitely look that up if you have the time. I have this kind of neat little Fibonacci Nature's Code video. If you just search on your platform, whatever you're using, Fibonacci Sequence, different things come up. Watch it. It's very interesting. Check you did our learning targets, and your homework is actually this value. This is 17. I did change this. I only want you to do these problems here odd only. These are sort of the meat of the problem. I want you to make sure that you know how to do each and every one of those. If not, I'll see you in office hours. Thanks so much for watching. I definitely hope this helped you.